since we are going to talk specifically about hazelnuts, I wanted to just bring everybody on the same page here. It's really great to see that we have so many participants. I'm looking at 161. That's pretty exciting that you can have that type of a reach for a 15-minute presentation today. Right now in the United States, 99% of the U.S. hazelnut crop is grown in the Willamette Valley of Oregon. I know a number of you already know this. Just want to talk about it a little bit though. Production continues to expand. They're now at about 90,000 acres, and they've doubled the acreage in the past 13 or 14 years. It's quite exceptional how large and how fast they've expanded. But this is supported by research and breeding at Oregon State University. But as most of you know, there's also a significant desire to grow hazelnuts in the eastern United States. And when I say eastern United States, I mean just east of the Pacific Northwest. So this can include the upper Midwest, the Great Plains, the Northeast, the Mid-Atlantic. So we're just going to lump everything else, just not in Oregon. Right now, there's a lot of momentum for planting hazelnuts, just like for planting chestnuts. With hazelnuts, orchards are being planted with trees from a variety of sources. Now, these aren't necessarily clones. They could be seedlings. They could be clones. There's a lot of things getting planted, a lot of plants getting planted right now. The industry is in its infancy, but it really is expanding. And there's, like I said, there's quite a bit of momentum. Hazelnut production is on the horizon outside of the Willamette Valley of Oregon. And at Rutgers, we've been working on hazelnuts since 1996. I've had the fortunate experience to have started or helped start the program with Dr. Reed Funk when I was a freshman, and somehow just never left. I'm one of the few people that my undergraduate research project turned into my graduate research project and turned into my academic career. So it's been quite a few years, over 20 years of working on this crop now. Eastern filbert blight is the main limiting factor of production of the European hazelnut. This is caused by a native fungus, Anisogramma anomala. We can't be upset with the EFB fungus because it was here before we were. It is native to the eastern half of the United States. And what we're trying to do, or some of us have been trying to do, or historically, is grow and introduce host plant. So we're trying to grow the European hazelnut. It happens that most, not all, but most of the European hazelnuts are highly susceptible to this fungus. I'm not going to talk a lot about the details of the fungus. Just know that it's quite devastating. It kills the plants. So it's not like a powdery mildew or a leaf disease that weakens the plant or makes it look ugly. It kills the plants. The other thing I want to point out also is that the European hazelnut is adapted to not only the Pacific Northwest, but really what we call the fruit belt of the northeastern North America. So you can see here within kind of this rough area I sketched out on the map. This includes parts of the Mid-Atlantic region, the Great Lakes region, really the USDA climate zones 6 and 7. They do best, the European species does best where we have moderately cold winters. They can take some cold, but also wet, hot, humid summers. If the European hazelnut is eastern filbert blight resistant, it can grow quite well and be productive in these regions. So going back to the beginnings of the Rutgers Hazelnut Project, finding resistance in European hazelnut, then breeding locally adapted cultivars has been the focus of the program. Today, I'm going to talk about hybrid hazelnuts, and you'll see sort of stepwise, it moves forward from just looking at the European species, because of course, we're excited about being able to significantly increase the growing range. So the early goal of the program, and I love how Gene kind of put this all into context, but we were really trying to identify resistance within the European hazelnut. This was the big deal here. So collaborating with Oregon State University, we screened tens of thousands of seedlings from controlled crosses. I should mention that we have collaborated very closely with Oregon State since the very beginning of our project, which allowed us to build off of several decades of breeding of hazelnuts before that time. So now we're looking at 25, 35, 45 years of perennial crop breeding that we're benefiting from as we of course step to the year 2023. So we screened control crosses from Oregon State, breeding selections, clonal plant material, and then I had the really fortunate experience as a younger person to make a lot of germplasm collections. And you can see this kind of colorful map here with a lot of red arrows. We were able to make seed collections, not looking for commercial cultivars necessarily, but locally grown cultivars all throughout the native range of the European hazelnut, and then into sort of introduced range. It's not native to Central Asia, but through the Soviet Union, they moved a lot of plant material. So we were able to go and just collect seeds of hazelnuts, bring them back to New Jersey. This is a lot of my graduate studies work, make these collections, bring them back, and then screen those plants for Eastern filbert blight resistance, adaptation to our climate, and of course, then kernel quality and yield. Eastern filbert blight is native in the eastern part of the United States, and we have very high disease pressure on the farm. So to Gene's comment of being able to phenotype the host plant, my early years were trying to figure out my screening methods, figure out this fungus. So when I saw a plant that didn't show disease or showed only a little bit of disease, I would be confident that it's showing some sort of host response. And then we could use it in breeding. I'm going to end the story here on the European hazelnuts because I want to jump into hybrid hazelnuts where we're actually going to use our native Corylus americana. But this is a big deal for us, especially since I've been working on this crop since I was 18 years old. In 2020, we released our first cultivars from the program. And this, like I said earlier, this came through these really great collaborations we had with Oregon State University. Maybe some of you out there have seen the names of these plants, Raritan, Monmouth, Hunterdon. And what's really exciting, we didn't just release these plants. These are now being sold by nurseries and they're being planted in the ground. Over the past 2 years, there's probably at least 15,000 trees, probably closer to 18,000 trees have been sold, mostly of Raritan and an Oregon State selection, which I may have time to talk about, the Beast. But it's kind of neat to be in the point where you can actually go and order these trees that we've been dreaming about for a long time. Of course, being sort of an ambitious plant breeder and working with a lot of people interested in growing hazelnuts in colder regions, if we had better cold tolerance, cold hardiness, climatic adaptation, we could really expand the production range. And this is really a great time for hazelnuts or for hazelnut research and breeding. There's actually multiple projects underway in the United States and in Canada, or Ontario in particular, to explore hybrid hazelnuts, so developing them as a crop. I'm going to talk specifically about the Hybrid Hazelnut Consortium, which is Rutgers, Oregon State, the University of Nebraska, Arbor Day Foundation, and the University of Missouri. But I'm sure many of you are also familiar with the University of Wisconsin, University of Minnesota. And I should say that we're actually joining forces. We just are in initial stages of putting a proposal together with this entire group. So we're really working closely with the Upper Midwest group. But there's also multiple private nurseries that are working on hazelnut breeding and selection and propagation and sale of plants and really industry development. It's kind of exciting. So quickly, I think many of you may be familiar with what hybrid hazelnuts are, but these are crosses between our wild American hazelnut, Corylus americana, which I'll show a slide about that. But in general, at least the northern selections are very cold hardy or cold tolerant, and also having evolved with the Eastern filbert blight pathogen, very resistant or highly tolerant. So the goal here is really to combine the improved nut traits, the domestication traits of the European hazelnut with the adaptation and disease resistance of the American hazelnut. So there's a lot there, but the genetic resources are available to do that. They cross freely and you get viable offspring, fertile offspring, I should say. And this has actually been going on for now over 100 years, at least efforts to do so, but it's really been intermittent. It's been just a few plant breeders here and there, and just how Gene sort of mentioned, plants are lost, records are lost, a few plants kind of squeak through and make it to the next generation. But we do have this really interesting history of hybrid hazelnut development that started, I think the first year, the first cross ever was 1918. So we're now over 100 years of hazelnut breeding. We've had breeding progress, but no commercial cultivars released. At this point, the most widely planted hazelnuts outside of the Pacific Northwest are mostly from seed-derived orchards. They're actually highly variable in terms of commercial nut traits, but they tend to be widely adapted, disease resistance or disease-resistant populations. and really convincing of their potential. So while you can say, well, you can't really make money growing hybrid hazelnut seedlings, well, they've actually inspired a lot of people to really think about this as a crop. And then now it's, turn it over to plant breeders and others, and how can we really cultivate and make selections. But it's really, there's a lot to be said with the people that have worked on this crop in the past. The American hazelnut, it's a small multi-stem shrub. It's widely adapted. You can see this. It's kind of an old native range map. I don't know exactly where it is to date, but it goes to some very cold regions. It grows on a wide diversity of soil types, even including very sandy soils in the upper Midwest. So it's very widely adapted and phenotypically plastic, I would say. You can grow it in a lot of different conditions. And like I said, it's cross-compatible with the European hazelnut. And what we're trying to do here is really not necessarily look at hazelnut as a new crop. This is a very old crop. It's been domesticated for thousands of years, really. And there's an international hazelnut industry. There's equipment, there's markets, everything's there for hazelnut. But it's not there when you have itty bitty tiny nuts with thick shells and plants that aren't able to be harvested with existing equipment. So you have two different approaches. You can develop equipment and markets, or I'm a plant breeder, when we say, well, why don't we try to get plants that can grow all across this native range, but have kernel qualities of the European hazelnut. I don't need to invent a new machine. No offense, because I do like the ideas of the other machines. They're really great. But personally at Rutgers, we can just buy an Italian machine to harvest the nuts. We buy an Italian cracker to crack them, and then we can sell them to people as hazelnuts. So that's been sort of our goal, is to see where we can get with hybrid hazelnut development to get that kernel quality that we can sell it on the international market, but also have high quality kernels that we can sell locally, because that's really where a lot of the focus is. As I mentioned, we have this group in the Hybrid Hazelnut Consortium, and I really just want to talk about one kind of interesting component that we're doing in terms of breeding, where I think we're excited over, or I'm personally excited over. But realize we have Oregon State, Rutgers, New Jersey, University of Nebraska, representing one of our harsher climates, and then of course, University of Missouri, which is a relatively new component. But the goal here is to help secure current production in Oregon. And when I say secure, I mean help them identify durable resistance and climatic resilience. As we look towards the 30, 40, 50 years from now, it's kind of worrisome what the climate's going to be like. And then, of course, expand commercial range across North America. And then the one thing I wanted to talk about is our multi-region breeding strategy with the goal of developing widely adapted cultivars. With the premise here that if we have a cultivar that can grow well in New Jersey, well in Oregon, well in Nebraska, well in the upper Midwest, or I'll say a set of cultivars, but we can identify those that are adapted in plastic where they can grow. And I see this, we have plants from Minnesota that grow really well in New Jersey. They grow well in Nebraska. Those may be the plants that can survive some of these really wacky climate fluctuations we're seeing, or these other issues in the future. So we're trying to do our best to develop plants that are going to be suitable for the long-term horizon. It's hard to know what's really going to work, but we're going to give it a shot. In terms of a breeding foundation, we'll have to give a lot of credit to Sean Mellenbacher, who worked to widen the germplasm base for hybrid hazelnuts with foresight back in the late 1980s. He worked with members of the Northern Nut Growers Association and asked them to go into their forests, their local hedgerows. I don't know where they found them, but to find American hazelnuts and send him seeds. He grew out hundreds of plants from many dozens of collectors all over the country. And what he did as a really strict plant breeder, he assessed them, he took notes on them, and he selected the best in terms of the traits he was interested in, one being bearing nuts every year, larger kernels, being able to get those kernels out of the shell or out of the husk, things like that. And he put together what I would call like a core collection. So he built a collection of less than 100 individuals. He also began crossing them with his own elite European hazelnuts. So he developed this hybridization breeding program starting in the 1990s. And when we started the Hazelnut Consortium, he openly shared. He said the Oregon hazelnut industry is not interested in these crappy interspecific hybrids. They have elite cultivars. It's like, so the university said, you know what, you can share this material, help the industry develop elsewhere. So he was so generous in sharing his plant material. He also used the early New York breeding selections and crosses, but I won't get into. But the main thing is he actually collected wild plants, he made selections, and he started to cross them with the idea, and then later using genetic markers to try to use the most diverse he can and to widen genetic diversity. He even began crossing his best F1s to make F2 populations, using genetic diversity based on DNA markers to cross wide parents. So he had this really great scheme in place. The other player in this, and I think this is really where it kind of gets interesting. And if you can picture, I have this pool of germplasm from Oregon State. Now I have this pool of germplasm to play with from the Arbor Day Foundation, where in 1996, they planted 5,000 hybrid hazelnut seedlings from the Badger Set Research Nursery in Minnesota. They grew them out, and it actually got them excited over hazelnuts. About 10 years after that, they started to work with the University of Nebraska. They put a graduate student on the project. They went through and evaluated all the plants. Don't know how she did it, but she did it. And she found the top 10 highest yielding plants over about a 5-year period. They were tracking these plants and they found the most consistently high yielding plants. So they were able to say, Tom, I've got the 10 best plants out of this planting, and here's the data to show it. And it was impressive. The yields were close to Oregon yields. So as a plant breeder, and this is just a picture, this is behind the lead lodge, it's still there. As a plant breeder, I get excited over this. Unfortunately, there was no Eastern filbert blight. So I've got their 10 best, highest yielding plants, but there's no Eastern filbert blight. They're adapted to these harsh Nebraska conditions, but are they disease resistant? I don't know. So what we did was, well, we clonally propagated those 10 best plants. We clonally propagated a whole bunch of stuff from Oregon. We brought them to Rutgers, where we probably have the worst disease pressure potentially in the world. I can be to blame for part of that, but naturally it occurs there. And we screened all this plant material under very high disease pressure. What that allowed me to do was to select the most resistant, most tolerant survivors, also select those that had the best nut quality and yields in our local conditions. So now I have Oregon, I have Nebraska. Then we start our breeding program. So here under our New Jersey conditions, we're crossing the Oregon, the Nebraska, European, interspecific hybrid, pure American, a whole bunch of different things. We grow out these progenies. 8 years later, we evaluate them for all the traits we're interested in, and we start to make selections. Here's just a pretty picture. But what we found was, even in F1 hybrids, we are now getting kernel quality traits that are very close to the yields of, or to the traits of interest of the European cultivars. And you can see here, the one I'll point out is Yamhill, which is for the kernel market. It's got basically a 1 gram kernel, 46% kernel to shell, basically. Those are our targets. 1 gram, anything over 42% is actually a pretty thin shell. And you can see here, and of course, this took about 10 years to get to this point, but here are some of our best selections, which actually have kernel qualities that would fit in the kernel market. And they're disease resistant. Are they cold hardy? We don't know yet. Here's a picture of pure F1 hybrids. And I like this slide because this shows, we had a couple parents that floated up to the top, which tends to happen in breeding programs. Here's a pure American hazelnut from North Dakota. We're crossing it with an elite OSU European hazelnut, and we're recovering resistant plants with maybe not top of the line kernel qualities, but very close. Much, much better than most of the things that are available in that region now. Wisconsin, Minnesota, we're expecting that these will be more cold hardy than the European hazelnut. We're not really sure yet. So what do? We go through this big breeding program, trying to combine all these different plant materials from different regions, selected New Jersey. We identified the top 50 out of about 3,000 individual plants. Then we start to clonally propagate them. Now remember that these are disease resistant in New Jersey and have commercial quality kernels. So exciting from our perspective, they grow well in our climate. But what's really interesting is, well, how are they going to do when we go across the country with them? So we now have trials Nebraska, Missouri, Minnesota, Wisconsin, and we have new ones in New York and Southern Ontario. The same set of about 50 clones replicated across these regions. So what we're doing now over the next few years, we're collecting data on these clones. Really, what's exciting to me is there's two things. We can find locally adapted hybrid selections, but what I'm really searching for are those that show wide adaptation. So we may find some top performers that actually perform well, it's my hope, across multiple regions. And this is, of course, being exposed to the pathogen, which is diverse across the range here. So hopefully looking for those that are durably resistant, but also in one sense, maybe climatically resilient. If you can grow in Nebraska, you can grow in New Jersey, and you can grow in Wisconsin and Minnesota, there's a chance that when the climate throws something weird at you, we've identified some of these plants that can handle it. And the early tests are showing that, so we're excited over that. And of course, we're going to use this information to continue the breeding program, because this is where we're going to learn about adaptation and resilience and durable disease resistance, and use a lot of the tools that Jean has mentioned in support of the breeding program. But I'll end here. The future does look bright for hybrid hazelnut production in colder regions. Like I mentioned, we joined forces with the Upper Midwest Hazelnut Development Initiative, and we have this opens up opportunities for sharing plant material even wider, although we've been doing that for a while, and learning from each other as we go. We're studying inheritance of eastern filbert blight resistance, and we'll be studying all of these other traits related to adaptation, phenology of bloom, cold damage, cold tolerance, as we go forward.